Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface and I show you how to actually write a C++ code and link it to a basically C++ library. So linking is something that we haven't looked at yet in this course, and I think this is a good time to look at it. So we want to use Java, and then we have a C++ library that has highly efficient code. So we want to use JNI to call those library, basically use those libraries. So we use JNI to basically call a C++ function that is basically a bridge to Java. And then that C++ function is going to basically call another function in the library that we want in the C++ library. And my example here is just a simple scientific library that has a function, let's say array function, that the math library of the JDK doesn't have, right? So let's say I'm doing some computation, I need to use a special function like array function or Bessel function or gamma function, something like that. And I have to go and look for it either in Java libraries or C++ libraries. And I always recommend to look for C libraries first and use JNI because computational libraries are much more efficient in C++ when you compile them with a purely Java version of those implementations. All right. So we looked at the basically the website of the GSL, GNU Scientific Library. It has many subroutines, sub-packages, and one of them is called special functions. And then first of all, these are all free libraries, right? Whatever you download from the GNU website, it's always free. You can use it. You can use it whenever you want. You can even modify the source code. I think it's also fine, but you can read the license file in the downloaded package. So this array function that I want is in the special package. It is in the special function subroutine. And what I can do, I can go to the online documentation, as I showed you in the previous lecture, and search for array function, and it brings me here, array functions, and it tells me there is a function called GSL underscore SF underscore array, and array functions have two kinds, AI or BI, right? So I can use any of these, and it also tells me which header file to include in my basically in my C++ code. So I have to include this GSL underscore SF, which stands for header special function. So SF means a special function underscore array, and I have to include this in my C++ code. The array functions are defined in the header file. And I mentioned in the previous lecture that when you install the C++ library in the default location, which is user local folder, it puts together all the header files of the library and puts them in the include folder, user local include. And then it also creates the binary file and puts that in the user local lib, which stands for library, right? So I can find this header file in the user local include. All right. So let's head to Eclipse and try to write our code. So in my Java perspective, I'm going to create a new package. Let's call this test 16. And here I'm going to create a class called array function. All right, and in the array function, I'm going to have basically a public, because I just want to call a function. I just defined as a static. It's very similar to the math library in the JDK. All the functions are static functions because there is no point of instantiating this object. And we can in fact make the constructor private. Public static double, I want to return a double. And this should be a native because I want to directly call a native function, right? The array function inside the GSL library. And AI, let's call this AR, AI. This is the first array function, and we pass a double. And public static native double BI, double X, right? So we have two array functions. This is the AI function, AI of X, and this is BI of X. And here I'm using Java convention and not capitalizing the first letter. You can if you want to, but it's not recommended. So I'm just going to make basically the constructor private. That's just because for math libraries, we don't want to instantiate them because right now this class doesn't have any state. It doesn't make sense because it's just a function call. It's a function call, right? So when I do this, I just go to C++ library, and let's also create another class for testing this array function. So test array function, and we have a main method here. In the main method, let's create a method called test1, and in test1 I'm just going to say public static void test1, and then double x is 1.1, and then, or maybe let's say something like minus 1.1, and then double result is array function dot ai x, and then sysout x. All right, so sysout result. Now we see if I run this, I get the unsatisfied link error, right? Unsatisfied link error. So we have to go through the steps that we are already very familiar with. The very first thing is I have to select this Java file, array function, and run my Java H tool to create the header file, and it automatically puts it here in the header folder of my C++ test16 array function. And then I need to create a source file .cpp file, which actually gets compiled by the compiler. Let's call it arrayfunc.cpp. And then the very first thing that we do, we include the header file we just created, header, and then test16 array function, and then we copy and paste this prototype, the two prototypes of the array functions, AI and BI. And by now you're already very familiar with these signatures. The AI takes a double parameter and returns a double. This one takes a double parameter and returns a double. All right. So we have the JVM pointer, and then the J class is a reference to the calling class AI. That's because this is a static method, right? So we are not having a J object reference. We have a J class reference, and double is X. Similarly, for the BI function, we have a JVM pointer, and then the class is the array function class, which is the calling class, and then X again for the J double. And the good news is that J double directly maps to a C++ primitive double, so I don't need to do any type conversion for these primitives. All right, so I highly recommend that when you're trying to do computation with C++, try to send primitive types to basically C++. So if I, for example, send a basically a capital double, all right, and this is a valid overload because the type here is a Java object, the type here is Java primitive. This translates into the J object, and then if you want to then get the actual value, because there is no unboxing, or the unboxing is C++, so what you need to do, you have to call a method, and you get the method of double value. Perhaps I'll show you after implementing this one, but I highly recommend to use primitive types or send primitive types to C++ whenever you are doing computation. For example, instead of sending a list of double, right, let's import this from Java util. Instead of this, definitely use send a primitive array instead of a Java collection. As far as you can, avoid sending Java collections to C++, right? So it's much better or much more efficient to send a double array to C++ instead of a list of double, right? But I guess we will look at all these examples. So I have my C++. I just need to get the function call, basically call the array function inside the GSL library, which is already in my user local, right? So how do I do that? I need to include the header file of the array function, and in order to do that, I have to first configure my C++ so that the include folder is basically included in the compiler path. So I go to the C++ build settings, and then in the tool settings I have the compiler, and it has an include, and so far we have included basically the include folders of the JDK, so that we have access to the JNI, but we can add another include paths. And I'm going to browse file system, and I'm going to basically go to let's see, go to the root, and then go to let's see, so it's, I guess it's hidden, so maybe I just directly type it because I believe it's a hidden folder. So user local include, and then I guess the name of the folder, let's go again to folder user local. So basically what we need in the from user local, we need to, and yes, this user folder is hidden, that's why I didn't see that. So we need to go user local include this GSL, right? And we can either add this GSL folder directly or just leave it as include. And by the way, note that this user local include is already in the compiler path by default. So user include, user local include. So I don't actually need to include it again, because when you set up a C++ project in the Mac OS or Linux, for example in Eclipse or any other IDE, it already always includes this user local include, and it also includes user include, right? So these are two different things. So this user local include is the default location for all the C++ libraries that you're installing. So the GSL is already there, so I don't need to actually include it. But if you install it in a different folder in your operating system, yes, you have to manually include it, right? So I recommend to always install the C++ libraries in the default location so that it automatically gets included in your compiler path. So this GSL folder is already included, and again, as I mentioned before, by convention, whenever we want to link or include a header file from this include folder, which is a compiler path include, we use the diamond notation, and I say GSL, and I need the array function. So array function is special underscore array. Okay, and let's double check that we can open this. So if I hit Control and then click on it, we are able to basically open this header file. All right, and then it has the definition for the array function, and then AI and BI, which is what we want. So because I installed it in the default location, the IDE already included it in my C++ project, so I don't need to go and manually include it. So once I include this, I can call the relative function. So I want to return a J double, and these functions return a double, I believe. Yes. And because they return double, and then in the Java, J double directly maps to double, I don't have to do any type conversion. So I just say array. Let's see what we can do here. What is the name of the function? So I guess it starts with GSL, SF, array, AI, this one. And it takes a double X, which I just passed directly a J double, and it requires a mode. So what is this mode? So typically scientific libraries, you can specify what is the accuracy, right? And you can say I want to be a single precision accuracy or double precision accuracy, because for the special functions like array, there are some algorithms that can give you an approximate value with a limited precision much faster than trying to give you a double precision value. So this GSL mode type, if I click it, it's just a type, and then it has a basically precision, double precision, single precision, and approximation. So here I just use a double precision because I want an accurate result. So GSL mode default, and I believe the default is still double precision, so double precision. So that's it. So I send a J double to this function, which is a C++ library, and J double is just double, so there is no problem, and it returns a double value, which I directly return it as a J double to Java. So here I return the BI, so GSL SF array BI, and again I send here and GSL double precision. That's it. So if I compile this, I get most likely a compilation error, and that's a linker error. So the symbol not found. So it says, okay, I'm trying, you included this header file for the ARI function, which has the symbols for the name of the function, GSL, SF, ARI, AI, and BI. But I cannot find them. Where are these? What's going on? What is this GSL, SF, ARI, BI? So where are they? I don't know where to find them. Because the linker, after you compile it, the linker has to find a binary file that corresponds to these symbols. So what we need to do here, go to the properties of the C++, and now in the linker, so this is something that we haven't looked at so far. In the linker, now we say libraries, right? And then we need to basically include libraries. So what are we going to include? Remember, we are going to include user, local. So you have to set the path, user, local. So actually what we need to do here, we need to add the folder to the library search path. So the library search path is user, local, lib, okay? And then let's see if I can open it actually. User, local, lib, yeah. GSL, dilib, GSL, cblast, dilib. These are two, and ARI function is inside this libgsl.dilib. And again, this was an alias to the actual versioned number of the dynamic library, which is libgsl.25, right? So we're just going to link against this alias, libgsl. So we add this folder. So this, actually we don't need to add it twice. So this folder includes all the dynamic libraries, right? The dynamic libraries that I want to link against. And then in the libraries, we have to specify the name of the library. So I just say GSL. And remember, this was an alias to the actual version number of the dynamic library. But that's fine. We can always link against the alias, and basically it automatically gets replaced by the actual name of the library, which was gsl.25.dynamic library. So we apply and OK. Now the linker can actually should be able to find and resolve these symbols, because it has access to that binary of the GSL file, right? Of the GSL binary file. So let's compile again. Now we are able to compile and it's fine. So let's look at the output here. It says, so obviously it does the G++, so it compiles, all right? So it compiles all the object files, and then creates the dynamic library, and it had no problem resolving these symbols. So if I copy and paste this binary, copy to my Java project, and then go back to my test ARI function and then run this. And obviously before that we need to load the dynamic library into memory, static system.load library, and native C is the name of the library, and hopefully this works fine. Yes, we are able to get the value of the ARI function, and obviously we can also do a sysout on the ARI function.bi, the second type, ARI function, the second type, and this should also work fine. Yes, we are able to calculate it. And obviously we can compare this against like the Mathematica. So I'm just going to quickly run Mathematica, create a new notebook, and then let's just say ARI AI, and then minus 1.1. So let's look at the full precision. 0.0533810510430522. So it's pretty much the exact same precision. And I can also use ARI BI and minus 1.1. And let's look at the full precision. 0.04432658674082 and again, that's exact full precision. So we brought an entire scientific library to Java just using the JNI. We didn't do anything else. We installed the scientific library GSL, and now we have full access to the huge amount of functions, that subroutines that it offers. So we can use it to make Java really powerful in terms of scientific computation. You can also use it for any other thing that you want. For example, you can download and install the OpenGL library for graphics rendering, and then you can build your Java project by using JNI and implement or call the functions inside the OpenGL library. That's another use case. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.